2 roving mics, which will be either side of the theatre. And so please raise your hand if you've got a question, and we'll try and get through as many as possible. John Palmer is here to chair the panel tonight. He's also an expert in his field, and so I'm going to pass you over to John to introduce himself and the panel. Thank you. Good evening.
Thank you very much, Katrina. Can everybody hear me, first of all?
Yeah.
Great, okay. So welcome everyone. It's really great to see everybody here. And hopefully we're going to have a really interesting evening with some fascinating questions later on. So please get your thinking caps on whilst you're listening to our speakers speak. So just a little bit about me, kind of why I'm here. I'm a local Petersfield resident. I'm currently Deputy Director for Energy Performance of Buildings at DLUC, the Department of Levelling Up Housing and Communities, which altogether must win the prize for the longest possible job title. Which means that I'm looking after building regulations for our future homes and also the government's Energy Performance Certificate service. But tonight I'm representing myself, so any views I express tonight are my own and not government's. So we're going to take you on a little bit of a journey this evening, I think, and we're going to start with the home, the building, as what can we do there and what are the characteristics of our buildings that could help with energy efficiency. We're then going to move out to community and community action, and then we're going to finally go out to the national and perhaps international picture and follow the money and look at how that can generate action. So that's the plan. I'm going to start off introducing our first speaker. And for each of our speakers, I've asked them for a fascinating fact which might not appear on their bio, just to give you a little bit of a human context. So our first speaker is Professor Mark Gaterell from University of Portsmouth. Mark started off his career in the Royal Air Force, and I'm ex-Navy, so another ex-military person on the stage, but has found his way into buildings and the efficiency of buildings along the way. And his fascinating fact, possibly linked to the Air Force, is that he's jumped out of a number of airplanes, always with a parachute. So Mark, over to you.
Thank you, John. Thank you to Energise South Downs for the opportunity to come and speak to you this evening. So what I've been asked to do is just think about the Skidmore report in the context of housing. Before I do that, I just want to share one paragraph with you from Skidmore. It's been kind of pressing at the moment, and it's warning against the start-stop approach to net zero policy and the effect that can have on investment. And I think we've already got an enormous amount of evidence from things like the cancellation of the Green Deal, which shows us that abrupt changes in policy really do have a significant effect on the confidence of people to invest in the construction sector. So after, it was unsurprising, I guess, to start to see headlines like this one in the Financial Times in response to recent government announcements. So I wanted to start with a plea, and it's not a political point, it's simply a plea, that if we think this stuff is important, then we need clear, consistent, long-term policy landscape to give the confidence of people to develop the products, the skills and the services that we need to deliver those policies. And those policies must be immune to the timetables, the vagaries of Westminster, regardless of what colour the government is. So, just a plea to start with. So what about Skidmore and housing? Well, unsurprisingly, the built environment and construction plays a large role in the report. What I want to do is just focus on a few initiatives that focus specifically on the domestic sector. These are improving energy efficiency, both in new build and the existing build. And what we're talking about there is improvements to the thermal performance of the actual building fabric itself, the building envelope. There's a 10-year mission to make heat pumps a widespread technology, so I want to think about the nature of rolling out a particular group of technologies. And also some consideration of the continued use and the development of the Energy Performance Certificate as a key tool to deliver that policy. I think the key point I really want to make this evening is when we're thinking about these policies, to ensure that they deliver the intended benefit, to ensure they deliver the benefits that we really need, what we fundamentally must understand is the actual performance of our housing stock. And that's important for three simple reasons. The first is, if we don't understand that actual performance, how can we establish a baseline that tells us what our current actual performance is likely to be, either in terms of energy consumption or CO2? And if we don't have that realistic baseline, how can we possibly measure any real progress we make to achieving our goals? If we don't understand that actual performance, how on earth can we ensure that the energy efficiency strategies that we adopt actually resolve the challenges that we have when we're thinking about the thermal performance of a building fabric or a building envelope? And a similar kind of point really also for the last bit, if we don't understand the performance of the building, how can we really understand what an appropriate low carbon or renewable energy technology is for that particular context? So you might say, okay, we've been building homes for a long time, surely we understand the actual performance of those buildings. Well, let's just have a quick look at some evidence. This chart is for new build. Up the vertical axis is some measurement of energy performance, the energy efficiency of the building fabric. Along the bottom, we've got a number of houses that have been included in this analysis, and associated with each of those houses are two bars. The red bar, which is the predicted heat loss, and the blue bar, which is the measured heat loss. And all this chart simply tells us is that there is a gap between the measured performance and the actual performance of these buildings. It tells us that this gap is variable and it can be very significant. And we'll find similar data if we looked at the performance of our existing building stock. Remember, this is new build. And I think it's important just to pause and remember how important the existing stock is. Our existing stock of buildings generally performs thermally very poorly, but we're going to be relying on it. 80% of the homes that we will be in 2050 already exist. So we've got a huge job to do to bring this existing stock up to a standard that it needs to be. And some people are saying we need to be refurbishing buildings to an appropriate standard at the rate of 1.5 homes a minute from now until 2050. If we're going to make sure those strategies that we deliver or develop for improving the performance of our existing stock actually give us the benefits we want, we have to understand the performance before we start. And as we've seen from some of those data, that is uncertain. I think the other thing, I'll kind of deviate slightly off of purely domestic. This is non-domestic. I think it's interesting. These are non-domestic buildings in the UK. We've got a whole range of them across the non-domestic sector, schools, offices, libraries. And each one of those coloured dots represents the performance of a building that was included in this analysis. So what this is showing us is the difference between predicted energy consumption and actual energy consumption. Up the side we've got some measure of that, and about a third of the route you might be able to see there's a line, and that's 0%. And what we want really is if we are able to predict the performance of the building, we want all of those coloured dots to be on or around that 0 line. So what this chart again simply tells us is that there is a performance gap. That gap varies significantly, and sometimes it is a very significant gap. I think interestingly on this graph, what we also see is that sometimes buildings consume less energy than was predicted. But that's not necessarily a good thing. It might mean that there's not sufficient air being pushed through a building to get rid of the moisture. So we'll get mould growth, we'll get damage to the building fabric. What we want to do is to be able to accurately predict performance. And we've just got a couple of examples here, but there's a whole range of data out there that tell a similar story, that tells us that we often fail to accurately predict the performance of a building, whether it's new build or whether it's refurbished. Why is that? A whole range of different reasons. I'm going to cover two tonight. The first one is that, certainly traditionally, compliance with building regulations has been based on design intent. What that means is compliance is based on saying what you are going to do, not actually proving that you've done what you said you were going to do. So that's a challenge. In recent years, there's been an enormous development in the technologies, the techniques, the skills that we need to undertake whole house or whole building performance evaluation. So much so that the British Standards Institute published a standard last year that looks specifically at this, sets out mechanisms through which we can do it. So perhaps it's time that we started mandating the use of the tools that we already have. Now, what I'm not saying is for a large residential development that we go out and test every building. But perhaps what we should be doing is taking a random sample of those buildings and testing them to get some understanding about how close we are to delivering the performance we say we're going to deliver when we comply with regs. One of the big benefits of that approach is that it shifts the burden, it shifts the risk of non-performance from us, the occupier, the owner, back to the developer and the contractor, where I personally believe that risk should reside. Now, I think it's important at this stage just to recognise that there are a wide number of builders, developers, contractors who already really understand this issue. They are putting up buildings, they are refurbishing buildings, and they are voluntarily proving the performance of those buildings post-construction, post-occupation. Some of them go as far as to guarantee the performance of those buildings post-construction, post-occupation. So we know it can be done. We know it can be done at cost, but at the moment, it's not standard practice. But it has to be. We have to roll this out at scale, and we have to roll it out at scale pretty soon. The other issue I'm interested in this evening is the tools that we use to try and help us estimate what the performance might be. And here we've got a chart that just talks about the energy performance certificate. Now, we saw earlier that that's going to remain a key part of the policy going forward, so let's have a look at what it tells us. Up the vertical axis, we've got a thing called heat loss rate. Now, what that is, quite simply, is the amount of time it takes for a building, a house, to go down, the internal temperature of a house to go down by 1 degree once the occupier turns off the heating system. Along the bottom, we've got the letter ratings from the EPC, from A to G, A being the most efficient, G being the least efficient. So what you would expect to see is the size of those blue columns to decrease as we went from A to G. And when we get to G, the least efficient buildings, it's going to take the least amount of time to lose that heat. What these data suggest actually is that the most inefficient buildings are those that are rated C and D, not F and G. So these data and a whole range of other evidence are starting to suggest that sometimes these EPC ratings don't tell us quite what they think we tell us. But we need them to be reliable. We need to be able to be very confident in the information that they are giving us, particularly because we are starting to see this, where the energy performance certificate rating is influencing the value of a house. Now, at one level, that's brilliant. We are, as consumers, are now shopping around and are willing to pay extra for something that performs. The challenge is, that we've just seen, as other evidence tells us, is that we can't always necessarily believe those EPC ratings. So the danger is somebody pays more for an asset that doesn't actually perform in the way they expect it to. So we have to get this right. So any review or development of EPCs as part of this Skidmore process of the policies must include the identification of any fundamental issues in those EPCs so that we can have confidence in them. We saw at the beginning that there's an initiative to roll out some technologies, heat pump technologies, broadly across the UK, and I think we have to be a little bit cautious about any suggestion that one group of technologies is the silver bullet to all of the challenges that we face. For example, air source heat pumps. Now, I accept that this technology is developing all the while, but there's a lot of evidence that suggests the efficacy of those systems is very heavily dependent on the nature of the building you attach it to. And by that, I mean the insulation level, the infiltration rate, all those other things. So what we need to do is, if we're going to consider air source heat pumps as an appropriate technology, that discussion, that decision, must be based on actual performance data. I find it difficult to understand how we can say it's an appropriate technology if it's based on assumed data, when those assumed performance data might be considerably incorrect. And if we do base that choice on assumed data, we potentially build up some real long-term problems for ourselves. And my biggest concern is that in 5 years' time, I'll be sitting down at the lounge, get a phone call, and somebody say, "Have you been sold an air source heat pump?" Start to get into that great challenge. So, doing all of that under today's climate is just the start. We also have to think about these things in the context of how the climate is changing and what effect that will have on our built environment. And these data come from the heat wave in Paris in 2003. It's a big, horrible, messy graph. All I want you to think about are two things. The first is that dotted line at the top, which shows you the variation in the maximum daytime temperature. And then think about these black bars underneath. And all this graph simply tells us, if you look at August 2003, it says that if we have a period of extended elevated outdoor temperatures,